complex fractions can be hard. The technique that we use when there's more than two fractions, so here we see there are four fractions. This is, well, there's technically five, but we're not going to count this big one. So here is a fraction, 9 over w minus 1. Here is a fraction. Write it as 9 over 1. Here's a fraction, 9 over w plus 1, and then there's our fourth one, 9 over 1. And a lot of times with fractions, students think, oh, I just need to get a common denominator and plug through the math. But in this case, to deal with this complex fractions, what we would call efficiently, in math, efficient will give us a correct answer with less steps, and we're less likely to make a mistake. So a technique that we're going to use, an efficient technique, is not to get a common denominator, but to actually multiply this entire fraction by 1 in the form of the LCD over the LCD of these four fractions. And really what that means is you multiply each term by the LCD over 1, and things will cancel and clean up. So look here, these two fractions have a common denominator of w minus 1 times w plus 1. And then here's the original problem, and what they're doing is showing you that they're multiplying by 1. That's this box that I'm making right now. That's the number 1. And in fact, I usually don't even show that work once I get going on these problems, but I think it's good to keep reminding you, you're only multiplying by the number 1 in the form of LCD over LCD. Now what happens is you take this w minus 1, w plus 1, and you distribute it here, 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 and here. So one thing that Alex does on this explanation that I would do different is I would really emphasize this is the LCD over 1. And then this is 9 over 1. This is the LCD over 1. This is the LCD over 1. This is 9 over 1, this is the LCD over 1, because then you really can see what's going on here. Remember, this is the LCD over 1, which means there's a w minus 1 factor on top, and it's going to cancel with this w minus 1 on bottom. So again, what we're doing here, just restrict your attention to this little box that I'm making. Okay, then what's going to be left on top is 9 times w plus 1, which we see down here. Now this one, remember, is 9 over 1, and this is w minus 1, w plus 1 over 1. Nothing cancels, so you've got all three factors there. And then on the bottom, again, this really should have been written w minus 1, w plus 1 over 1, so you could really see that this w plus 1 factor cancels with this w plus 1 factor on the bottom. And then what's left is 9 times w minus 1. And then over here, again, this is over 1, nothing cancels. You're left with 9 w plus 1, w minus 1. Now, what's happening between this line of work and this line of work is the w minus 1, w plus 1 is really a difference of squares. If you FOIL it out, which is multiplying two binomials, what you're going to get is w squared, then w, then minus w, then minus 1. And so that plus w minus w goes to 0, and you're just left with w squared minus 1. Okay, then they do the same thing on the bottom. And a lot of students are going to want to distribute the 9 and blah, 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 blah. And don't do that. Just do FOIL this, FOIL that. You get these. Now, really, the slick way to do it right now would be to factor out a 9 and cancel it. Now, Alex doesn't do that, so I'm not going to do that to you. Here, the 9s got distributed. See that? 9w plus 9 plus 9w squared minus 9. That's just distributing that 9. That 9, that 9, that 9. Again, 9s are all going to cancel in a minute anyway. Now we've got combining like terms. This 9 and this 9 go to 0. So then I'm left with 9w plus 9w squared, that term and that term. Similar thing happens on the bottom. That 9 and that 9 go to 0. Then you have 9w minus 9w squared. So we're really close here. Now this is what's left. And you can see that the top has a greatest common factor of 9w. The bottom has a greatest common factor of 9w, leaving us with 9w on top to cancel with the 9w on bottom. And we have 1 plus w over 1 minus w. Voila! You could, back here, get a common denominator and then combine like terms, get a common denominator, combine like terms, and then, to do this division right here, you would take the reciprocal and multiply. But the reason we don't do it that way is it is not efficient. So in math, efficiency equates to less steps, and we're less likely to make silly mistakes. This technique is multiplying each term by the LCD over 1. We are not getting a common denominator, we are using the common denominator. This is a particularly hard problem. If you don't get it and you're just hanging on to bits and pieces of it, that's okay. Okay, there you go. Bye.